Good morning, everyone. The name of our lecture is High Integrative Function of Central Nervous System. About what we are going to talk today, about electroencephalography and its diagnostic value, about sleep and its physiological mechanism, memory and its neurophysiological mechanism, motivation, emotions, and their physiological mechanism. So let us start. High integrative function of central nervous system, they will include consciousness, control of sensory and motor functions, sleep, memory, language, motivation and emotions, intelligence, and ability to study. Morphological substrate of the high integrative functions will be cerebral cortex, thalamus, basal ganglia, cerebellum, and limbic system. Main brain regions involved in the mental activity. So, in the mental activity will involve the primary motor cortex, primary somatosensory cortex, also somatosensic associative area, which is located in the parietal lobe. Primary gustatory cortex, Wernicke area, and Broca's area, which is responsible for language. Then primary auditory cortex, which is located in the temporal lobe. Visual cortex, which is responsible for located in this, in the occipital lobe. Then prefrontal cortex, olfactory associative area. About some of them, mainly about the prefrontal cortex, Broca's area, Wernicke's area, also about visual, primary auditory cortex and primary visual cortex. We are going to stop today and discuss about them in context of the language, in context of the emotions and motivation. Before we are going to talk this, let us identify what is the electroencephalography. Electroencephalography is used to detect the electrical activity of brain. Mainly it is used clinically for diagnosis of epilepsy or brain death. When we talk about electroencephalography, we could detect several patterns. So alpha rhythm, mainly which will be recorded from the parietal and occipital regions. It's common for a person which is awake, relaxed, but with closed eyes. In case when the person will open eyes and have some kind of high mental activity or receive visual stimuli, they are going to receive beta waves. Theta waves, they are emitted from temporal and occipital lobes. They're mostly common in the newborn. It's registered in adult by superficial sleep. And delta wave, which will be emitted in a general pattern. They're common during the deep sleep and awake infant. In awake adult, indicated brain talks about the damages. Now let us go on. What is a sleep and the sleep-awake cycle? Sleep is defined as a state of partial loss of consciousness or unconscious condition from which a person can be aroused by stimulation. This distinguishes sleep from the coma, a state of unconsciousness from which a person cannot be aroused by even the most vigorous stimuli. For the most part, cortical activity is depressed during the sleep, but brain stem functions such as control of respiration, heartbeat, blood pressure, they will continue. Even environmental monitoring continues to some extent, as illustrated by the fact that strong stimuli immediately arouse us. In fact, people who sleepwalk can avoid objects and navigate stairs while truly asleep. Sleep consists of the several stages. So the first stage, it is the drowsy stage. The second stage is light sleep. The third one is a moderate sleep. The first deep sleep, and the last one is rapid eye movement sleep. What is the differences during the stages 1, 2, 3, 4? The process of respiration, heartbeat is going to decrease. This means that the process of respiration is going to become slowly. The same about the heartbeat becomes slowly. Muscles are going to relax. Eyes will not move. So person is going in this situation going in a deep sleep. But in the case of the rapid eye movement sleep, during this stage, the person is going to see dreams. In this stage, we have a high activity of the cerebral cortex. the heartbeat could increase, the respiratory rate will increase, the activity of the eyeballs are also going to increase. In this stage, as I told, the person could see the dreams, but also during this stage, the cerebral cortex will process information which it received during the whole day. What are the main centers of the what is the main importance of the sleep? The stage number 4 and stage number 5, which is the rapid eye movement sleep, are important in different ways. First of all, slow wave sleep is presumed to be restorative, the time when the most neural mechanism can wind down the basal levels. So it means that the body is going to relax. When deprived of sleep, we spend more time than usual in slow sleep during the next sleep episode. A person persistently deprived of rapid eye movement sleep becomes moody and depressed and exhibits various personality disorders. Rapid eye movement sleep may give the brain an opportunity to analyze the day events and to walk through the emotional problems in dream imagery. Another idea is that rapid eye movement sleep is reverse learning. According to the hypothesis, accidental repetition and meaningless communication continually occur, and they must be eliminated from the neural networks by dreaming in the cortex to remain a well-behaved and efficient thinking system. In other words, we dream to forget. Alcohol and some sleep medication like barbiturates suppress rapid eye movement sleep, but not slow wave sleep. On the other hand, certain tranquilizers such as diazepam reduce slow wave sleep much more than rapid eye movement sleep. So we could see that there is a very important function of the first stage of the sleep, which is mainly important for relaxing of the body, for relaxing of the cerebral cortex. So in this situation, for restoring of energy. And rapid eye movement sleep is mainly important for analyzing the whole information which you receive during the day, for imaging production of dreams, and also it is the whole hypothesis is important for process for reversing of the learning. What is the main centers of the sleep? What part of the cerebral cortex controls sleep? First of all, we are going to talk about the about the cerebral cortex. Then it will be a thalamus. It mainly receives the whole sensory information from all areas except the olfactory. And then the sensory information is going to be analyzed and put it in your dreams. For instance, hypothalamus and reticular formation. Mainly reticular formation is responsible for maintain your sleep-wake cycle. When reticular activated system will decline, cerebral cortex activity will decline as well. Thus, lesion of the reticular activity system nuclei result in unconsciousness, which means they result in the coma. Also, ventral-posterior nucleus of the hypothalamus are responsible for synthesize neuropeptide, which is called orexin. It also takes part in controlling of the sleep cycle. When the production of this orexin is going to decrease, this will lead to the stage which is called drowsiness. Another part of which is responsible for control of the sleep-wake cycle, it will be suprachiasmatic nucleus, which receive information from the visual cortex. So we know that during that night period of the day, eyes don't receive any kind of visual information because due to the darkness. So the darkness some extent, it will darkness which is enter the eyes will transmit it to the visual cortex and further will transmit it to the suprachiasmatic nuclei, which will detect the night part of the day and will be responsible to responsible for sleep, responsible for a feeling of the stages of the sleep. Okay, and nonetheless, as reticular formation, then suprachiasmatic nuclei, hypothalamus, altogether responsible for controlling of the biological biorhythm 24 hours cycle, 24 hours 24 hours biological cycle of the day part of the day and night part of the day. Now let us go further and talk about the memory. What is memory? Memory is a process during which person try to presume information, to capture it, to store it, and further to use it. How we can divide memory? We could divide memory in short-term memory and long-term memory. Short-term memory are also called working memory. It is the preliminary step as well as the power that let you look up a telephone number, delete, and then never think of it again. So it's for several seconds, even minutes, when you try to remember something, but further you will not remember this for a long period of time. The capacity of short-term memory is limited to 7 or 8 chunks of information, such as the digits of telephone numbers or a sequence of words in an elaborate sentence. In comparison to this, long-term memory seems to have limitless capacity. Also, short-term memory have a limitless capacity. Also, it cannot recall numbers much longer than a telephone number we can remember. Scattered of telephone numbers by communities than to long-term memory. Mostly long-term memory is a type memory during which you remember information for a long period of time. This happens due to the reversing of information, repeating of that information for several times in this case, and understanding this information. And in this case, you are going to remember it for a long period of time. Now, also we could divide memory in case of what kind of information we are going to remember. It could be declarative type of memory, during which you're going to remember the names, faces, words, or dates. It is related to our conscious thoughts and our ability to manipulate symbols and language. When fact memories are committed to long-term memory, they are usually filled along with the context in which they are learned. For instance, when you think of your new occurrence of joy, you probably picture him at the basketball game where you met him. And non-declarative memory, mostly it is memory of procedural skills like playing the piano, motor memory like riding a bike, or emotional memory, your pounding heart when you hear the rattlesnake nearby. These kinds of memory are acquired through the experience of usual repetition. They don't preserve the circumstance of learning. In fact, they are best remembered in the doing. So you don't have to think through how to tie your shoes. Once learned non-declarative memories and had to unlearn it. Okay, factors which will affect to transfer information from the short-term memory to the long-term memory. The first and main important factor is emotional state. We learn best when we are alert, motivated, surprised, or aroused. For example, when we witness shocking events, transferal is almost immediate. Norepinephrine as neurotransmitter involved in memory processing of emotional charges events is released when we are excited or stressed out, which helps to explain the phenomenon. Rehearsal or repetition of the materials enhanced memory. Association, when you try tying new information to old information. Altering store in long-term memory appears to be important and remembering facts. And automatic memory, not all impressions that become part of long-term memory are constantly formed. A student concentrate on a lecture speech may record an automatic memory of the pattern of the lecture time. Memories transferred to long-term memory take time to become permanent. The process of memory consolidate apparently involves fitting new facts into the various categories of knowledge already stored in the cerebral cortex. Structural basis of the memory. So, when we talk about memory, we should mention first of all about prefrontal cortex, which are responsible for involving the sequence of events, but not the events themselves. Hippocampus, it encodes and transfers new information and responsible to maintain the long-term memory. Cerebellum, mostly involved in non-decorative memory, memorizing the movement, different kinds of motor skills. Medial temporal lobe, not visible, encodes and transfers new explicit memories to long-term memory also. The hippocampus. Amygdala have the connection with the hippocampus, and it's mainly responsible for emotional aspects of the memories. What clinical symptoms of the memory disturbance? It could be antegrade amnesia, which means the inability to absorb new information, most often associated with lesion of the hippocampus. And retrograde amnesia, it's an ability to recall the information that the patient knew before the moment of violation. It is most often associated with lesions of associative portion of the cerebral cortex. So when it's antegrade amnesia, when it's difficult to remember something new, and retrograde in case when it's difficult to recall information which you have before, which you received before. Now let us go to another part where we're going to talk about the language. Main centers which are responsible for language, which we're going to discuss, it's a Broca, which programs sound patterns of speech, and it is Wernicke's area, which is responsible for planned content of the spoken words. But before these two regions are going to be activated, we need to receive the kind of information from the ear, like when you hear words, or from the eyes when you see something. So let us discuss the pathways. 1A. To speak about something seen, the brain transfers the visual information from the primary visual cortex, from the occipital lobe, to the angular gyrus of the parieto-temporal occipital associative cortex, which integrate inputs such as sight, sound, and touch. Then, after that, or another variant, when we receive information from the ear to speak about something heard, the brain will transfer the auditory information from the primary auditory cortex also to the angular gyrus. So nevertheless, information from the what you have seen or what you have heard will go first of all to the angular gyrus. After that, the information is transferred to the Wernicke area, where the choice and sequence of words to be spoken are formulated. After that, this language command is then transferred to the Broca's area, which translates the message into the programmed sound patterns. And after that, information are going to send to the primary motor cortex, which is mostly responsible for controlling of the movement of the muscles of the face, of the movement of the tongue, and production also of the vocalization and production of that speech. So the sound program is conveyed in the process area of the primary motor cortex that activate appropriate facial and tongue muscles for causing the desirable words to be spoken. So there's three types of aphasia we could talk about. It's expressive aphasia due to the damage of the Broca's area. It's in this case it's difficult to program sound patterns of the speech. Receptor aphasia, it's a damage of the Wernicke area, during which it's difficult to understand about what you should speak, to make the plan of this of the words which you're going to speak. And motor aphasia, due to the damage of the motor cortex, mainly due to the damage of the primary motor cortex, which control the vocal muscles. It means that the person will understand about what he or she should speak. She will have, or he will have the patterns, the program sound patterns of speech, but it's difficult will be to produce the speech. So it will be some kind of scandic speech problems with the production of it. So I would like to show you two videos in which you will see the two examples of aphasia, the expressive aphasia and receptive aphasia. This aphasia mostly happens due to the stroke in the cerebral cortex of the patient. So give me a minute and I'm going to show you.
Hi Byron, how are you?
I'm happy. Are you pretty? You look good.
What are you doing today?
We stayed with the water over here at the moment and talked with the people for them over there. They're diving for them at the moment. They'll save in the moment. He'll have water very soon for him. With luck for him.
So we're on a cruise and we're about to
We
get to
will
Juneau.
store it right here and they'll save their hands right there for them.
And what were we just doing with the iPad?
Right at the moment they don't show a darn thing.
With the iPad that we were doing. Like here?
I'd like my change for me and change hands for me. It would happen. I would talk with Donna sometimes. We're out with them. Other people are working with them. I'm very happy with them.
Good.
This girl was very good and happy. And I play golf and hit other trees. We play out with the hands. We save a lot of hands on hold for us, other hands. I don't know what you get, but I talk with a lot of hand for him. Sometime. Am I talk of any more to saying?
All right, thank you very much.
Thank you very much. I appreciate it, and I hope the world lasts for you.
Thank you. It's been a pleasure. Bye-bye.
Have a good day.
Okay. So what's your name?
Scott. Oh, no. Sarah Scott.
That's right. And how old are you?
I can't.
Try.
I can't.
Oh. You're 19. 19.
Yeah.
Yeah. And what happened to you?
Stroke.
You had a stroke last year.
Yes.
And what happened? Can you remember what happened?
School and English class.
Okay.
And I book and I read it aloud, but I can't because stroke, and so I send and also it's the same as the same of kind of thing as you know.
Pins and needles.
Yeah,
like pins
the
and
same, and also arm as well.
Leg.
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 Yeah. Yeah.
And what happened after the stroke with your speech?
Well, I can't.
You have speech problems.
Yeah.
Do you know what that's called?
Yeah. Aphasia.
Yeah, good, good. I haven't heard you say the word before.
I write it down.
And that helps?
Yeah.
Okay. So you are going to go to university. What are you doing now?
But
What do you do now? Every day?
I'll speech the speech.
Therapy?
Yeah.
Okay.
And also riding.
Riding what?
Oh. Horses
Yeah, good.
and and connect.
Connect, yeah. You like Connect, don't you?
And it, yeah.
Why do you like Connect?
Aphasia, so I can the same kind of problems and speech, like yeah.
Okay. And how do you feel?
I'm fine.
You're fine. That's good. Good. What helps you to speak? When you write things down, it helps you, doesn't it?
Yeah.
Sometimes.
I don't know, but I can't. Sometimes I write it down because it's easier, and also speaking is easier, so I don't know.
A mixture.
Yeah.
A mixture.
And I can't write like one word, I'm fine, but sometimes, but a long sentences, I can't read, I can't write.
Can you read a book?
No.
Do you want to read a book?
Yes. But I can't.
You liked reading,
Yeah.
didn't you? And what about your friends? Do you still see your friends?
A little.
Is that hard for them?
Yeah. Because I can't speak a little, but it's harder. And I can't, sometimes it's harder because speaking, I like my friends, like it's too hard and I don't like it, so it's hard than friends, than
Family?
yeah.
Yes. You're getting better though, aren't you?
So now let us talk about the emotions and motivation. Emotions are, I'm sorry, give me a minute. So emotions and motivation. Emotions are the subject reaction of a person, the action of external or internal stimuli manifested in the form of pleasure or dissatisfaction. In emotion, there are two significant interrelated sides: the subjective, manifested by psychological phenomena, experience, anxiety, passion, pleasure, or joy, and objective, for which the tension of the psychological systems of the organism is common. And what is the motivation? Motivation is a physiological state that arises in the case of need to satisfy one or another organism needs. As a rule, basic emotions arise when deviated vital constant, glucose level, body temperature, osmotic pressure from their optimal value. At the same time, a focus of excitation is formed in the center of emotion in central nervous system, which creates a behavioral program aimed and returning the rejection parameters to their optimal level. But first of all, let us discuss about the emotions, how we can classify them. We could classify on the general biological emotions, which are inherent in both animals and humans. They are related to the disturbance of homeostasis and are aimed at satisfying vital needs. The need of food, drinking, self-defense, reproduction. Among them, there are food and ritual research, aggressive, protective, and sexual emotions. And one might say human or high order, which are common only for the person, is described related to the satisfaction of the personal and social needs, like intellectual, moral, aesthetics, interaction with other members of the group. These high emotions are formed on the basis of the conscious. So they have inhibited, and I'm sorry, and reaction emotions are divided into negative, dissatisfactive, and positive, which means the satisfactive. So generally there is about 6 basic emotions like anger, disgust, fear, happiness, sadness, and surprise. These emotions come with us when the person is only infant and newborn, so that is why it is the most basic and common emotions. How we can identify what region of the cerebral cortex is responsible for this or that type of emotions. This we could done by the functional magnetic resonance imaging, which was this kind of examination, fMRI, was used in patients, and the patients will receive different kind of pictures, which pictures in which rise different kind of emotions like surprised, angry, and others. And as a result, due to the fMRI, was measured what kind of region was activated during this specific type of emotion. The emotional brain. Now let us discuss what structures are responsible in emotions. It's the limbic system. In case of the limbic system, we are going to talk about the amygdala, which is responsible for the fear, hippocampus, which is responsible for memorizing, a region of the nucleus accumbens, olfactory bulb, which sends information to the amygdala, to the hippocampus. It makes such kind of network, thalamus and frontal lobe. Also, we are going to discuss about 2 pathways. It's the dopamine and serotonin pathways, which take part not only in emotions but also in motivation part of our behavior. So what is the emotion? Emotion, it is equal to detection and reaction. So first of all, you detect something, and after that you are going to react on it. So here we have a picture which describes that the person detects a snake. So from information from the eyes, the visual information, I'm sorry, goes to the visual thalamus, then it will send directly to the visual cortex. But besides this, information will go to the superior colliculi, which is a part of the oriental reflex, and also information will send to the amygdala. Amygdala is responsible for such emotion, which is called fear. Amygdala will send direct information to the hypothalamus, which is a part of the not only the humoral regulation, but also the neural regulation, is responsible for the function of the immune system, autonomic system, and as a result, we are going to receive fight and flight response. Generally, you will run away from the danger. Amygdala, the main function, is regulate fear and aggression. It is involved in tying emotional meaning to our memories, reward processing, and decision making. This function of the amygdala, it could appear different kinds of phobias, panic disorders, depressions, schizophrenia, and Clever-Busse syndrome, which is related to the sexual disorder. How we are scared. Here we could see different 2 kind of pictures. In the first picture, when the lions will be near you, so I mean in the wild, you are going to be in the safari. For instance, let's imagine that you will be in the safari and you will not be in the bus, which will be closed, so you will as a result you will feel fear. You will be scared about the lions and you're going to run away from them because it is a dangerous situation. But when you're going to the zoo, when you will see the lion behind the gate or behind the window glass, you will think that what is a nice and calm animal. Why in the first situation you're going to be scared, but in the second variant, when you're in the zoo, and you will feel safe. This happened because in case of the first situation, information, not only amygdala take part in production of the fear, also cerebral cortex, frontal lobe is responsible to control your emotions. So in the first case, we see that you will be in a wild environment and you have the very close connect with the animals, so you will feel fear. So your cerebral cortex also will understand the frontal lobe and understand situation, detect situation that is the danger situation. But in case of the second picture, when you will be in the zoo, information from the amygdala, from the visual cortex, will send to the cerebral cortex, the frontal lobe, which is going to which will understand that you're in the safe position, because you are behind the gate, you are behind the glass, so the lion couldn't do anything for you. That is why you were going to feel safe. So feeling safe, not scared, will be done due to this cerebral cortex, due to the high levels of the mental activity, which is going to control your emotions. But sometimes when when cerebral cortex is not able to control your feeling of the fear, we're going to receive situation which is called amygdala hijack. So you are treated about something, amygdala panic button, yes, is going to fires up, and due to this fires up, cortex, it will fire, so excitatory process will be so big in the amygdala, which will spread to the hypothalamus, pituitary gland, and as a result will release hormones, adrenaline, cortisol, autonomic nervous system, mostly sympathetic division is going to fire up. So as a result, cerebral cortex will not able to control your emotions. So it will be such situation when you will not be, your emotions will not be under the control. They will fire up, and you will produce even some kind of if it's better to say unconscious or unthinking things. For instance, what happened with the Mike Tyson during the fight, when he bites the opponent's this one. Yeah. Why does this happen? Due to the amygdala hijack, the emotions were not under control of the cerebral cortex. We will have fire up of the amygdala. It's like a panic button, and as a result, he could not control he couldn't control he couldn't control himself, and he did such kind of unthinking or under things like biting the ear. Hippocampus. The main function of the hippocampus is responsible for formation of memory. It's important. It will play important role in spatial processing and navigation. This function of the amygdala to the antegrade amnesia, about which we talked previously. Now let us go on. So let us look on this pattern which describe that when people say that listen to their heart, what they really mean is that their limbic system is bossing their frontal lobe surrounds. So this is right. Limbic system is mostly responsible for emotions. Amygdala, which is a part of the limbic system, is responsible for emotion. And generally, when we have more or like firing up of the emotions, it means that the limbic system will be bossing, and it will not listen to the frontal lobe. Like This is the limbic system, the red one, which say you are going to listen to my feeling damage. And the frontal lobe will say, dude, all right, just stop yelling. So cerebral cortex will not control sometimes the emotion. Parts of brain which is related to the motivations, it's the same limbic system. As hippocampus, it will be responsible for a part of memory. So when you do some kind of things, hippocampus, like that memory, it's going to remember that things, that kind of events, sequence of events, which lead for rewarding, and as a result, you're going to repeat to receive this rewarding once more. Then amygdala is the same, the fear. Fear when you are scared about something, and this kind of emotions will also take part in production of the motivation. Prefrontal cortex, and as I told you, dopamine pathway and serotonin pathway. Dopamine pathway is mainly responsible for the key word for dopamine pathway. It is the wanting. That if you want something, you are going to do some kind of some kind of events, and as a result, you will receive it. So after you want something, you will do it, and you will see the reward. So this reward will be responsible to make such kind of neural network in the cerebral cortex, and as a result, you will see the experience, and afterward you always will try to repeat this kind of situation to be rewarded. So when you study very hard, you will receive your A mark, and as a result, you will be rewarded by your A mark. Now you know how to learn. Well, now you know what to do to receive this good mark. So you're going to repeat it. So this experience which you have, you're going to repeat it continuously to receive that reward. For rewarding and for wanting process responsible dopamine system. Certain pathway is responsible. The key word for certain pathway is I like it. See, if I like it, I'm going to do it. So it's also further take part in situation to encourage you to do something, to be motivated in your work. So how we can classify the human motivations? The first one is basic, it's physiological motivation for breathing, for food, water, sleep, so homeostasis. So you will do everything to receive, to be rewarded by food, to receive food, to sleep, to breathe. Safety, security of your body, security of your family, of your health, of your properties. Love, belonging, so like friendship, family, sexual intimacy. So it's motivation for having a family, for having a friends. Esteem, self-esteem, confidence, achievement, respect of others, and respect by other people. And self-actualization, which means morality, creativity, problems of solving, and lack of prejudice, accept of the facts. Thank you for your attention. Goodbye.